Actually, this exercise should call change of base. Okay, change of base. What is change of base? For example, I want to know roughly how large is log 2 5. Okay, I can't simplify it. I can't do some calculations. How large is log 2 5? Okay, on some scientific calculators still, there's nowhere to help you to put the base in it. Well, you can't put any base. There's only two base for you. One is a nature base E, and the other one is a base 10. Okay, you can't do base 2 or base 5 or any other base. So what we need to do is, I want to change that to the base that I can put into the calculator and help us to work on it. So this is the purpose of the change of base formula, why it created. Okay. I think before in old days, like in my mom's age, they actually really used the change of base formula to help them to find values. They have base 10 and give out a lot of tables, okay, base 10 2, base 10 3, base 10 2.5, what is it? There's a lot of values they're listing. But like nowadays, you have your CAS calculator, you can put any base in it. We don't really need to use change of base formula. So this formula just give you more harder questions. Okay, so it's not really a practical use anymore. It's more for like, do you know this thing? Okay, how you can use it, how this question can be done by change of base formula. So it's not a practical use anymore. We have the CAS, we can put any base in it. So we still learn it. How we change of base. So let's have a look. A to the power of x equals to y. As the definition for log, x must be log ay, right? That's the definition for what is logarithm. Log ay. Base a also is y, log ay. Okay, let's do something else. Tell me what base you want. Well, I don't want base a. Tell me any base. Any base you're interested in. 10. Okay, 10. 10 is a good number. Okay. What I want to do now is log 10 both sides, because ax equals to y, right? Ax equals to y. So log 10 ax must be equals to log 10 y, right? Well, same as log 10 to log 10 2. It must be equals to each other. Is that correct? Yes or no? Yes. Ax equals to y, the log 10 of that number equals log 10 of that number. It must be the same. So what I can do here is I can bring the x into the front by the law number 3. By law number 3, I can just bring it into the front. Because that's the power, I can drag the power into the front. So what my x will equals to in this case is log 10y divided by log 10a. Compared to two answers, x is equivalent, they are equivalent. So log ay equals to log 10y divided by log 10a. That's the change of base formula. I have successfully changed base a into base 10 divided by base 10. Okay, base 10 divided by base 10. Okay, I'm not only restricted to change the base into 10. I can actually change to any base I like. Okay, any base I like. So I can make a base, well, instead of log 10 both sides, I can log c both sides. Well, any number, any constant. Any constant which is positive and not equals to 1. I can log base c any number. Well, 1 is fine, 1 is not fine. 2 is fine, half is fine, and this is fine. So x times log ca equals to log cy. So x will equals to log cy divided to log ca. Can I have a look? C and C. Okay, C and C, 10 and 10. I can change that C to any number. Okay, base 10 is fine. Base 8 is fine. Base half is fine. I can change C to any number. That's the change of base formula. And what equivalent to that? Don't forget, your x equals to log ay. So log AY is actually equals to log CY divided by log CA. They are equivalent. They are equivalent. You just solve it by two methods. The two answers must be the same because it's the same x, same power. So log AY equals to log CY divided by log CA, which C can be any number greater than 0 and not equals to 1. Okay, so this can tell us a lot. That is actually the change of base formula. So what is the change of base formula? Is log AB equals to log CB divided by log CA. Well, I just changed the y into b. So log AB equals to log CB divided by log CA. So I can change it to any base, but must be two numbers divide each other. And B first and then A. B first and then A. Okay, again, you don't need to know the proof, but I have a very important result by using change of base formula. Log AB equals to 1 over log BA. So what is that? Log 3, 4 equals to 1 over log 4, 3. Why is true? I will use change of formula to help you to work on that. Okay, have a think. This is base A, right? On the right hand side, what the base become? What's the base on the right hand side? B, okay? Left hand side base is A, right hand side base is B. Okay, I will make right hand side change of base to base B. So left hand side equals to log AB. I want to change of the base to something. So change of base is log something divided by log something. The base I want to change, as I said, I want to change to base B. So it's base B and base B. How about the two original number? The B is on top and the A is at the bottom. Log CB over log CA. And C can be any number. I can change C to B. I can change C to anything. Well, not necessary to be any other numbers. It can be just this number I want, this B. And log BB is 1. And then we have log BA. And that equivalent to right hand side. So I have proved here that log AB is 1 over log BA. Log AB is 1 over log BA. Okay, that's not really helpful in year 10, but year 11 is quite helpful. You can use that. Well, any question you don't know what to do for logarithm, you can think about change of base formula. I think other than those 5 on the previous page, I think change of base is the most helpful one. Okay, change of base is the very powerful one. I can always change of base when I don't know what to do. Okay, I can always do that. All right, let's have a look at the question below. I want to solve the following, use base 10. Okay, use base 10. Okay, what I have here? I'll say log 10, 4 to the power of x equals to log 10, 2, 5, 6. X times log 10, 4 equals to log 10. Okay, 2, 5, 6. Okay, 2, 5, 6 divided by 4. 64. 8, 8. 4, 2. 4, 2. 1, 2, 3, 4. 4 fours. 4 to the power 4. And what we have is x times log 10, 4. Equals to 4 times log 10, 4. So x equals to 4. So x equals to 4. Well, I can really easily do with that, like that's 4 to the power 4 and x is 4. That's much easier. but like they want us to show base 10. That's how we show that's a base 10. Well, next one, 2x equals to 10. X equals to log 210. And I don't want base 2. What I want is base 10. So it's log 10, 10 divided by log 10, 2. I changed the base from 2 to 10. From 2 to 10. So it's a base 10, and 10 result first and then power. So x is 1 over log 10, 2. 1 over log 10, 2. That's a base 10, not base 2 anymore. Okay, next one. Next one is 30. Okay, 0.7x equals to 2/3. 2/3. X equals to log. Well, I would say that's a 7 on 10 over 7 on 10. That like 0.7 is 7 over 10. Change of base, x is log 10. 2 on 3 minus log 10. 7 on 10. I can do a bit more to that. Okay, I'm not necessarily doing that. I can do a bit more. That's log 10, 2 minus log 10, 3. Divide by log 10, 7 minus log 10, 10. So x is log 10, 2 minus log 10, 3 over log 10, 7 minus 1. Well, you can keep it like this line. Okay, this line is fine. I just want to do a bit more. Like I can use the formula. I want to show you the formula more. Okay, so I can use the second formula. Log am over n equals to log am minus log an. Just separate that a little bit. Okay, and log 10, 10 is 1. Okay, log 10, 10 is a 1. So I can change that into a 1. Okay. The next one is use change of base formula to write the following with base 5. With base 5. Well, that's base 3 now. I want to change a base 5. So it's log base 5 divided by log base 5. I have 16 here and I have 3 here. This 5 needs to be like a subscript, like really smaller on the corner. Okay, like that. Well, I can do a bit more to that. Like what's 16? 16 is 2 to the power 4, right? I can say that's 4 times log 5, 2 divided by log 5, 3. I can simplify it a little bit. Well, not necessary. Again, I can do that. I just want to show you the formula, how you can use of that formula. Log 2, 7. So it's a log 5, 7 divided by log 5, 2. Your base and the result cannot be on the same line. Okay, the base needs to be a little bit smaller compared to the result. Like 5 needs to be smaller. Okay, be careful with the notation. The last one is log 5, 13 divided by log 5, 9. I can do more to that because 9 is a square number. So that's log 5, 13 divided by 2 logs of log 5, 3. Because 9 is 3 to the power of 2. 9 is 3 to the power of 2. Okay, that's it for change of base. Okay, that's it for change of base. It's very easy, a purely straightforward formula, and you can just apply to it. Okay, that's it for today.